This video is on exercise 1A of A-level further maths core 1, questions 6 to 8. Now in question 6, we are given that z2 minus z1 is 7 plus 2i, and we should use this in order to find the values of a and b. So it's very simple because we know the value of so let's just write this in another form. So we know that z2 is equal to is minus 3 plus bi, and z1 is a plus 9i, but it's minus z1, so it will be minus a minus 9i is equal to 7 plus 2i. Now let's solve the left hand side, so let's simplify that. So minus 3 minus a, minus 3 minus a. So this is the real part of this number. And then the imaginary part is b minus 9 times I, because we have bi here and minus 9i. So b minus 9 times I. So this is the imaginary part. So here is the imaginary part, here is the real part. And this is equal to 7 plus 2i. So this is going to be a very useful technique, and you will be using this a lot when you are working with complex numbers. So when you equate coefficients, and that's how you can work out the values of unknowns in such questions. So in this case, your real number must be equal to the real number of the right hand side, which is 7. That means minus 3 minus a is equal to 7. So you can solve this equation and you will get minus 10 is equal to a. So this is your real part, and you do the same thing for the imaginary part. So b minus 9 is equal to 2 and b is equal to 11, so that the value of a is minus 10 and b is 11, and that's what we wanted to work out. And notice that both a and b are real numbers, but when you write bi, then that will be an imaginary number. 7. Given that z1 is 4 plus I and z2 is 7 minus 3i, find in the form a plus bi, where a and b are real numbers. So yeah, we should work out each of these. A, we have z1 minus z2. So z1 is 4 plus I, and minus z2. z2 is 7 minus 3i, but minus that will be minus 7 plus 3i. And this is equal to minus 3 plus 4i. B, 4z2. So this means 4 times z2, and z2 is 7 minus 3i. So we get 28 minus 12i. C, 2z1 plus 5z2. So 2 times z1, z1 is 4 plus I, plus 5 times z2, and z2 is 7 minus 3i. That is 8. So 2 times 4 is 8 plus 2i, and then the second bracket, 5 times 7 is 35 times minus 3i, it's minus 15i. Now the real parts are 8 and 35. 8 plus 35 is 43, and the imaginary parts are 2i and minus 15i, which gives us minus 39. 8. Given that z is a plus bi and w is a minus bi, where a and b are real numbers, show that so parts a, z plus w is always real. So this question is actually very simple, of course, when you are doing A-level maths, because when you want to prove this in a very rigorous way, that can be different. But yeah, now we are doing A-level maths, and A-level further maths. So in that case, we know that z is a plus bi. So let's just write that down, plus w, which is a minus bi. So a plus a is 2a, bi minus bi is 0. And that's it, because now we got 2a and we know that 2a is a real number. Therefore, z plus w is always real. Now for z minus w, which is part b, we should show that is always imaginary. Again, z is a plus bi, this time minus w, which is minus a plus bi. So a minus a is 0, bi plus bi is 2bi, and bi is always imaginary, and 2bi is also imaginary. So this is always imaginary, and we have proved both of, or we have shown both of these. That's all true. So that's it for this video. Thank you for watching. Make sure to subscribe for more videos. I'll be doing all of the exercises, and so yeah, if you subscribe to my channel, you won't miss those videos. Good luck.